Hello and welcome to my 10th video. I hope you have your coffee mug ready for this session of Zero to Pass the Interview with Vault, Hashicorp's Vault. I think this is one of the hardest videos that I have done because I was really looking for practical matters I can tell in a short video. And there are a lot of concepts that they are introduced in here, and I wanted to make sure that I'm covering everything that is needed basically to pass the interview, or at least getting your hands dirty working with the Vault. So there are a lot of approaches to storing passwords and secrets in the production. First of all, the most trivial one is store it in your code and then ship it with your code. Very basic, you are still saving the password on the Git, and you cannot change the passwords on the fly. Or it's not just passwords, also the configurations. So that's a big issue in there. The second way that most people are using it is saving the passwords as configurations inside the Git repo, and then while you're mounting your application or deploying your application, you are doing this deployment also on the side. So firstly, you're deploying your application, and then you're going to deploy the configuration. Still, you're saving the password in the Git, but you're some kind of having like dynamic way of changing the configurations. That's a better way of doing it. The third way of doing it is storing it in your CI/CD. For example, we are using CodeFresh, storing it in the CodeFresh's Vault, and then injecting them while deploying it. If you are using any approaches like GitOps, that is basically storing all your resources in the Git repository and then using an agent like Argo CD to deploy them in Kubernetes, so still you are going to store your passwords in Git. It's not going to be secure unless you make your Git repository very secure. There are some applications that they are coming up that they are saying that we are going to solve this issue. So what they do, for example, I have a video on sealed secrets. It tells you that I'm going to seal the secret or encrypt your secret, and then as a resource like custom definition resource. And after you have implemented or deployed the password or deployed that configuration file, then I'm going to open it and decrypt it and make a secret out of it. So that's another approach to it. If I can say, like, regarding the security standards of deployment, or like security standards, this one is better than storing it in Git, but still you're saying that the Kubernetes or inside the Kubernetes network is a safe place to store the stuff and make it available to people. So if there is a hacker that breaks into the Kubernetes cluster, still they can see the secrets. There is a better way to do that, and that is actually using a way of API calls to get the secret. So it's like that you have an application that is totally secured and it's storing your passwords both on the rest. On the rest means that it's storing it securely, and on transit. It means that when you're calling it to receive basically something, it's going to be secured. So both on rest and on transit, it's going to be secured. We have some cloud providers that they're giving it to us. Like AWS has key management service, Azure has Key Vault, and GCP has secret management. You can see all of these cloud providers have their own Key Vault services. And also we have IBM Cloud, not totally suggested, with Secret Manager. If you can just go to other clouds, it's highly suggested. But if you're stuck with IBM Cloud, this is what they provide to you. Anyway, AWS, Azure, and GCP, they are providing it to us. It's a good offering. If you can convince people to use this kind of like key management service, that's totally suggested. Why it's different? Because you are not storing it in Kubernetes, you are not storing it in Git. You are just storing your passwords inside a pretty well-managed Key Vault. There is also another option. If you have enough resources to spare, totally suggested to have your DIY Key Vault. DIY your vault. Do it yourself. Bring it there, install it there, and maintain it. Usually it needs a team. at least one dedicated person is needed. Like that dedicated person should know everything about Vault and all those things. So there are like, for example, if you want to talk about the Hashicorp Vault, there is like associate certification for them to go there and learn about how they can really like work with the Vault. So the whole job of one person is going to be just managing Vault. Vault as a general, key Vault as a general, it has three aspects to it. The first aspect is the clients that they're connecting to it and probably retrieving the password. And then you have some kind of identity provider aspect to it, and that is, for example, when Vault is in Azure and Azure is using Active Directory for identity management, then you can basically use that identity management system to give access to your people inside the Vault. You don't need to create all those users or all those roles in there also. You need to make the policies in there. And the third aspect to it is like secrets or secret management. What kind of secrets do you want to support? Like you can have key value secrets. That is like you say, this is a name, this is a secret, the simplest form of the secrets. Or you can have database as a database engine as secret. What it does is like every time your application wants to connect to it, it just finds out, for example, your application says that I want a authentication method to a MongoDB, and Key Vault will give it to him. The other aspect that we want really the Vault to have, or that Key Vault that we are making as general to have, is audit. If somebody is going to break into your system, you want to know about it. So you should have that audit layer in there. As I told you in the previous slide, you need encryption, both at rest and in transit. What are the good to haves? One of them is dynamic secrets. So it means that you can rotate your password every 30 days or so. That's very suggested. That's the latest way of doing it. And then the next one is separate password for different clients. If you have one application requesting the access to MongoDB, your Vault is going to be giving it different password than the other application, so that you can manage, if there is like a breach, you can just manage changing the password, and just that single application is going to go down instead of like if you have 1,000 applications. And then one of the good things to have in the Vault is you can write your own plugins, as it's happening with Vault currently. So talking about Hashicorp's Vault in particular as like a key engine, we can have different authentication methods. We can have different clouds in here. Also, IBM Cloud is unfortunately supported. We have, even you can use JWT OIDC. That is, you can have, for example, Keycloak as your identity provider, and then you connect it to the Vault. So we are going to talk about the Kubernetes part in this video, how you can use Kubernetes and leverage Kubernetes as authenticator. And we are going to have secrets engines. We talked about key values, that is a name and a secret in front of it. For example, username of database or something like that. We can have database as secret engines. Basically, for each application, we are going to generate a new password, and we can even give access to the cloud. Key Vault or Hashicorp Vault is something that I totally suggest for a big company. They are going to automate a lot of things that they are doing on a daily basis, and it's going to help them a lot. That one person that they're going to pay for like managing the Vault, totally worth it. But for a small company, well, I don't know, or a small team, I don't know. That's the tricky situation in there. And then we are going to have different clients. Vault is written both for humans and for machines. That's something that I really like about this technology. Let's talk about dynamic secrets a bit. So how it happens is that firstly you have security team going in and like defining MongoDB Atlas as a secret engine. And then Vault is going to create some kind of like database credentials. And then you have your application on the left. So application wants some kind of credentials to connect to the MongoDB Atlas. Vault is going to create it and then give it to the application, so application can use that specific username and password that is created for that specific application to connect to MongoDB Atlas. We have different ways of consuming secrets with the key vaults. The one that they are cloud managed, usually they are like managed by API. But if you are having your vault, you can have API environment variables. Also, this one is given by the cloud providers. You can have Kubernetes sidecar and templating agents, our vault agents, and we can have third-party pass-throughs. There are a lot of concepts in this slide, so don't worry about it. We are going to get back to it once in a while. Okay, what we need for this video basically is one cluster and your terminal as always. We are basically going to follow up a tutorial by Hashicorp, and we are going to talk about the concepts while they're coming up. First of all, what we are going to use in here is this one, that is the Git repository of Hashicorp Vault guide, and we are going to specifically go to this folder. Here we are going to add the Hashicorp as Helm repo, and here we are going to install Vault as dev enabled. So what dev enabled has, it's basically has unsealing in place, because if you're going to install it in production, there is a pretty tedious task of sealing the keys. You can see in here that is like saying that running Vault in development is going to be initialized and unseal the Vault itself. It's not recommended for a production environment. Just call an expert for it. We are going to get into the Vault. What we are going to do now is set a secret inside the Vault. This command says that enabling the secret engine of KVV2. So KVV2 is like a key value version 2 secret engine, and now it's enabled. We are going to create a pretty easy username and password, or like secrets for a database, just fictional database, db read-only username, db secret. We are going to just look into the config here, that exact place that we created the secret, and you can see in here data is in here, password we have created this one, this is db secret. So we can see the data in Kubernetes authentication configuration. There are some kind of aspects to here. First of all, we are going to say that enable the authentication by Kubernetes. Okay, we are enabling it. If you want to just go in and check back with the slides, we said there is authentication methods and there is Kubernetes as authentication method. What happens in here is we are going to retrieve our JWT token, that's our pod's JWT token, and then we are going to get the host of the Kubernetes, and we have the CA cert of the Kubernetes. All of these ones, they are mounted automatically inside your pod. We are going to just take a look at our token in here. Here it is. This is our JWT token that is assigned to our pod when it was created. Let's come back to here. You can see that inside the pod we have kubelet. Kubelet is going to mount this JWT token that is created by Kubernetes. It's going to mount it inside the container. That's how we are retrieving it. It's also mounting the Kubernetes port and address. Let's just use this one. Here it is, Kubernetes port and address, like the kube host. And now we can go in and basically copy it and telling Vault that this is how you should config the Kubernetes as authenticator. The next one is creating a policy. So we are going to create a policy named internal apps, and we are going to say that as a capability it can read the data. Let's copy it, bring it here. Okay, successful policy uploaded. This one, just you can skip this slide. So the policy says that the path is this one, data database config, the path that we created our key value, and then you can just read it. Let's create a role for that policy. So what we are saying in here is that service account name should be internal app, and the namespace should be default. So if there is an application, even if it's using the same service account name and it's in different namespace, it cannot connect. These two should really match. Like namespace should be default one and service account should be internal application. And we are creating a role that is internal app. Now we can safely exit from here because we have done most of the configuration. Let's go and create a new service account. Pretty simple way of creating it. You can see in here, service account, and just putting a name for it. That's simple. The next one is launching an application. So if you see here, the org chart application that we have in here, there are some points that we should take care of it. One of them is service account is made in here, internal application as a service account. These files are inside the guide of the vault. So it's been created. We can just get pods. Okay, get pods. Just notice this one. It means it says 1 of 1 ready. It means that the agent or injector is not there yet. And now we can inject the secrets. So as an injector, or like if you want to enable the injector, we should add these annotations to our system. So the first annotation says that agent inject true. It means that just enable the injection. The second one says that the role that I want to use is internal app. So if you remember, we said there should be a service account, there should be a role, and there should be a namespace. The namespace is there. We are in default. The service account is there. We defined it as internal app. And now we are going to say this is the role that we want to have. In this secret that we created, internal data database config, go and mount it inside this file, database config. What we are going to do is just patching our deployment. We have patched our deployment. And if we get the pods now, you can see in here, it's terminating the previous one and it's creating a new one that has the injector sidecar to it. Let's go and see the logs in here. Renewed the auth token. It means that we have got the auth token in here. So let's come here. Here is the part that you are getting the auth token. So it means that all of these processes, that they are about like 5 processes that we are having in here, all of these steps has been done very simple or automatically with the sidecar. We are passing in our JWT token, and then the vault is going to ask Kubernetes if that JWT token is right. And Kubernetes is going to give back like, yes, that's true. This is the service account name, and this is the namespace that is associated with this JWT token. And then the vault is going to ask for like service account name and that one, see if they are authorized to access which secrets. And after that, it's going to create a token that is auth token and give it to the container, or in this case, to the sidecar. Again, renewed auth token. It means that we have got the auth token. This is the way that we are getting the data. It's in a map condition that it says that password is this one, username is this one. That's map data. We can have a template in here. And here it is. We can apply it as a template. How it's going to do is that you can see in here, this is what we are going to have in the config1, config.txt, database config. And this is a template that we are going to use to bring it to there. We are going to say that with the secret that is found in this target, go in and populate this template and put it in here. That is database config.txt. So it's a Postgres address. This is the username. This is the password, and it's going to populate this line and then put it in there. Let's apply this and see the results. Okay, you can see here it is patched. Let's just get the pods. It's initializing. We are having it as one-liner, as you can see in here. If you have extra time, I highly suggest going over these documents and applying it one by one yourself. But basically, when you finish this document or this video even, you should be able to name the main concepts that are happening in the vault and how they are done. And what else? Let's see. And how the authentication is done. So to review the authentication again, what we have done, firstly we went in and just created the roles, the policy. Firstly, we created the, which one we created? The roles or the policy? We created the policy firstly, not the roles. And then we created the roles. So it's step 2, it says that create the roles. No, we created the policy and used that policy to create the roles. And then we saw that on the sidecar, when we identify the service account, when we identify the role, it's going to log in or automatically log in and get the auth token. And it's also, this part is automated. That is like getting that auth token to receiving some secrets and then putting it or mounting it inside the pod. I think that's it. You have learned a lot about Hashicorp's Vault. Congratulations and have a great day.